This is 1.5 of GCSE Math, adding and subtracting fractions. So really this whole video boils down to one golden rule. When you're adding and subtracting fractions, they must have the same denominator. And as long as you bear that in mind, you can answer absolutely any question on this. So let's say that I had a third plus another third. Well, the only important thing to do here really is to not do 1 plus 1 is 2 and 3 plus 3 is 6, because then you end up with 2 6, which we know from 1.2 is equal to a third. And obviously a third plus a third is not going to stay as a third, so that is clearly very wrong. What you should do is leave the denominator alone, so keep the denominator as 3 and simply add the numerators to get 2 thirds, because if you imagine you have a third of a pizza and then you've got another third of a pizza, it's just one of one thing plus one of another thing means you get 2 of that thing, so it's 2 thirds. And that's easy because they have the same denominator, so you easily replicate that denominator and then just add the numerators. Similarly, if I have 2 sevenths plus 3 sevenths, same denominator is good, so we can replicate the denominator and just add the numerators. 2 plus 3 is 5. What happens if they don't have the same denominators? Well, we have to make them have the same denominator, and we know from 1.2, which was simplifying fractions, we can change a fraction to make its denominator whatever we want. So if I had, for example, a third plus a half, well, I need these to have the same denominator. We can't add them when they have different denominators. So we need to think of what would be a good denominator to change these two fractions to, and we need a common multiple of 3 and 2. If we write the 3 times table out, 3, 6, 9, 12, so on, and the 2 times table out, we need a number which is in both of them, and what we can see there is 6. Alternatively, you can just realise 3 times 2 is 6, and so that is a common multiple. So we need a third plus a half, and we know that's equal to something over 6 plus something else over 6. Okay, let's change this third into a 6. Whatever we do to the numerator, we do to the denominator, and vice versa. So to get 3 to 6, we multiply by 2, and so we have to multiply that numerator by 2 as well. So the third is the same as 2 sixths, and this 2 is multiplied by 3, and so we have to multiply that 1 by 3 as well. So a half is 3 sixths. So now we have a third plus a half is equal to 2 sixths plus 3 sixths, which we know we have the same denominator now. So replicate the denominator, add the numerators, it's 5 sixths. What happens though if, say, I have mixed numbers? Well, you don't want mixed numbers. Mixed numbers are annoying to add up, so we want to change everything to improper fractions, which we've done in previous videos. So if you want to just do a little side note, and we want to convert 1 and a third to an improper fraction, we know that we do the 1 times 3, which is 3, plus the 1 gives us a 4 on the numerator, and a 3 on the denominator. So this is equal to 4 thirds plus 4 sevenths. And now we need a common multiple of 3 and of 7, and that is, well, we can just do 3 times 7 is 21. So this is something over 21 plus something else over 21. We can convert if we go to our little side working box. 4 thirds is something over 21. The 3 to the 21 is times 7, so we multiply the top by 27, which is 28. Sorry, multiply the top by 7, which is 28. And similarly, 4 sevenths, the denominator is being multiplied by 3, so multiply the numerator by 3 also. Is 12 over 21. So we have 28 over 21 plus 12 over 21. Replicate the denominator and add the numerators. 28 plus 12 is 40. It's 40 over 21. I'll do one final example. I have 9 over 8 plus 2 and a third. Again, we have a mixed number here that's not of much use, so I'm going to convert that to an improper fraction. This will be 2 times 3 plus 1 on the numerator, and it will stay as 3 on the denominator, which is 7 over 3. So now we have 9 eighths plus 7 thirds. And now we need a common multiple of 8 and of 3, and 8 times 3 is 24. So we know it's something over 24 plus something over 24. 9 eighths equals something over 24. Well, that's times 3. So this also is times 3. 9 times 3 up here, which is 27 over 24. And the 7 thirds, similarly, the same logics we've been using. This here, see, is times by 8, and so here is times by 8, which is 56. So now we have 27 over 24 plus 56 over 24, which is this, and 56 plus 27 is 83. So 83 over 24 is our final answer. And that is as simple as adding fractions gets. Subtracting fractions is the same logic, you just subtract the numerators instead. So if I had 2 thirds minus 1 third, replicates the denominator again, and then just 2 minus 1 is 1. And again, if they have different denominators, say we have 8 ninths minus the 7th, different denominators, make them the same. We need one thing over 63, and another thing over 63, because that's a common multiple of 9 and 7. 9 times 7 is 63. 8 ninths, well, here to here is times by 7, so here to here times by 7, 56, 7 63 times by 9, and so 1 times 9 is 9, and then 56 minus 9 is 47 over 63. And that is all there is to 1.5. See you in 1.6.